This is the bias board. I went ahead and pulled it out. If you see the previous video on this, the original wire, the ground wire broke off right here. Usually the negative lead of that is the ground wire. But in this case, it snapped off here. So I'm going to remove all this. While I wait for that to beep, I do want to point out a little battery review. I bought these Energizer Max 9 volts about 2 weeks ago for my meter. Now, one of my meters need a new battery. I bought this 2-pack. This one lasted about a week. I thought, that's a fluke. Not a fluke, but sorry, no pun intended there regarding the meter. So I put in the second one. This one lasted another week. So these only lasted a week. And the previous battery in that same meter was just like a generic Amazon. It lasted like 3-4 months. So I don't know if I've got a problem in the meter. It's drawing too much current. I don't think so. I think I just got some dud energizers. That makes me sad. Anyway, I'll report back if it turns out to be a problem with my meter versus the battery. Can't catch me because the rabbit done died. And again, these original parts will be returned with the amp. Let's see if this lead might be the jumper going beneath. I believe it is. Yeah. All right. So again, I'm going to cut it with a little bit of excess so I can bend that over. Let's get the diode and resistor out. It's a 470 ohm. It actually measures about 450. It'll be returned with the amp. And this old diodes last a really long time, especially the silicone diodes. But I have had Fenders from the 60s with failing diodes. And as they're so crucial to the health of the output tubes and hence the output transformer, and so inexpensive, I prefer to change them out preventatively. I don't want someone to lose an original output transformer to maintain the original diode. That's a upside down view of value, in my opinion. Again, just like on the filter caps board, I want to get all this old solder out. Without branding myself in the process. It's almost all of it. All right, better place to be. A little bit that doesn't want to fall out. Again, I'll just bend these over on themselves as necessary. Actually looks pretty good already. I just need to bend this one a little bit more. Snip off the excess. Get rid of all these little bits of old solder. Some of them stuck to the towel. Better to the towel than to my flesh. All right, I'll clean up the old eyelets a little bit more. I like for them to be shiny. They put a paint on the diodes on a lot of these Fenders. I'm not sure why they painted the joints on the diodes only. Maybe it was a different production line that did the bias and rectification boards, and they had to use that paint to show that they had inspected it or something. Anyway, that paint can get in the way of applying new solder. So I make sure that it's up. And heating it, the eyelet does a lot of it, and then I'll just go in there. Make sure it's off the surface of the eyelet. Loosen up any old flux in the process. All very familiar from earlier in this video on the filter caps. All very familiar with a few hundred videos on this channel, probably. Wonder how many times I've done this. I wonder how many pounds of old flux I've removed from things over the years. Is it worth it? Let me work it. I think so. Because I've never had, at least in the past 10 plus years where I've been working at the level I've learned from my mistakes. I've get to a point now where I find this is best practice. And since I've been doing this kind of work on these, I've not had any instance where, hey, it didn't work after I did that, or I missed something. That very thorough attention to detail, if nothing else, promotes a vigilance and a checking of one's work as one goes. Now again, just like on the other one, I like to get it wet with some isopropyl, both sides. Clean up all the old yuck. Trying to wipe it with fresh paper towel so I'm not smearing old yuck all over the place. And then I will heat up all the eyelets. You can just see the moisture being driven out. All right, let me get a fresh bit of paper towel. Okay, I'm sure what I'm seeing is what you're seeing and vice versa. Normally I don't do this for bias boards because it's so easy to eyeball it. But for the sake of the video, and I do this when I'm populating an entire board, take out the measurements. So for the for the resistor rather, I want it to be pretty much just 1 inch. Tolerance band to the right. Huh. Did I miss up something? Oh. Sorry. I misread the calipers. It should be 1.1. That's easily done. So let me just clamp that old bend a little bit flatter. See, I could have edited all this out. You never know. 1.1 is different than 1, isn't it? There we go. Oops. Tolerance band to the right. Crimp over on itself. The resistor, that may be less than 0.8, which is the minimum. Not the resistor, the diode rather. Yeah, it's 0.722. Smallest this has is an 8. So I will eyeball this. And I like to do it so the 4007 The 1N4007 print is going up. I think I overshot that a little bit. Just barely. Resistor tolerance band is to the right. That is almost purely cosmetic, following the standards that Leo or Don Randall or whoever at the production facility chose. But the anode cathode layout of the diode is very much not cosmetic. So for the bias, this band must be to the left, the incoming voltage. That'll give reverse voltage rather than the positive voltage. Along those same lines, the new capacitor must have positive to ground because it's going to be a negative voltage. And this is a Vishay 47 microfarad 100 volt. The original cap there is a 25 microfarad 50 volt. 50 volts is pretty low. That bias supply can exceed 50 volts, negative 50, but same thing. But 25 is really low. 47 is kind of the sweet spot. You can go as high as 100 microfarad. You don't want to go over that due to the rise time. You don't want to have the bias come on more slowly than your B plus ever. That's a longer subject. So put that in there, put that in there. Kind of finesse it a little bit. I want to have that little bit of slack, so when it's all in place, there's not any tension at the cap leads at the body. You can do that one a little bit better. And once again, even before solder is applied, everything is pretty much in place mechanically. Now let me find my bus wire because I want to put a new length of wire here that'll go to chassis. This 20 gauge will do nicely. It's a short length, maybe 3-4 inches. Not a ton of current in a bias supply. So there's no need to use 18 gauge or 16 gauge or anything crazy. That's probably a little bit more than we'll need. But bus wire is cheap. Rather do it once and trim off any excess than get it a little too short and then have to remove anything. Let me kind of straighten this out. Again, it comes coiled up, which drives me nuts because you get all these little kinks and micro bends. There's probably some tool to pull this through to undo that, but I have not found one that works without causing other problems. Let me put the calipers up. All right, let's see. If anyone knows a magic tool to feed this through and make it nice and straight without doing any damage, please put that in the comments. I'd love to know. I've tried all kinds of things. Anyway, this will work. Let me give it a start, bend, and pull it down on top of itself, like so. And what I like to do is take this lead and crimp it down like that. That really hooks it on there. And while I'm going to do the rest of the solder in here after it's in place, after these two screws have gone down and put a lot of torque on there, I'm going to go ahead and flow a little bit of solder right now just to make sure that that doesn't move around on me. That is reliable bias supply. I put it inside the amp and then I'll do all the solder bits up. I just do the solder afterwards because these things are like this, and once they're screwed down, they can want to move, and if they move and get little micro fractures in the solder as a result, I could miss a problem. Coffee. Whereas if they're locked in place mechanically, then you solder, you're reinforcing where they want to be rather than having it fight. I should probably not turn around and look at the floor while speaking. Doop-a-doop-a-doo. All right, so I've got this board with these 3 wires that will go to it. So this one is the main bias, which goes to the pot. This is the most crucial one here. This is the one that must not come loose. So this one goes in underneath. And it can go here or here. In this case, I'm going to take it to where it was originally, which is here. I guess you're not seeing all this, are you? Damn it. Sorry about that. All right, so this is the wire that goes to the bias pot. It goes through this hole in the board and then from the bottom here so that it has a lot of strain relief. It's just hard to get it started through that hole. Crimp that over on itself. Pull the excess, and then when that gets screwed down, that'll get locked in place. The secondary from the power transformer goes in here, and this, which goes to the tremolo, goes in here. Those can go in place after everything else is attached. So let me get the backing board, which is here. I got a little bit of old flux I'm going to get off real fast just because I can. Doop-a-doop-a-doo. Just a matter of knowing that even the stuff that no one will see when it's in place is done well. I'm not worried about the remaining ISO. That'll evaporate out, especially as I get a solder to it. And I put the screws, which hold it in place, I put them in the doghouse cover so I wouldn't lose them. And there they are, unlost. So let me start these here. Are you seeing what I'm doing? Yeah, okay. Then I'll slide the backing board over them. I'll screw the backing board in place. Pre-bend the ground wire. Slide that beneath the heaters. Slide this roughly in place. This didn't have the little angle bracket there. This was just 2 pieces of fiberboard. All right. And the last one I did like this, I believe it was a Bassman. I tried to do it the way most people would do it, which is just putting the boards in place and then screwing down. And I had a dickens of a time. This is the way I usually do it, but I thought that'd be fine to do it the other way. It was much less successful the first try than this. So now it's in place. Can you see where the focus is? That's not going anywhere, so now I can apply the solder to it. Where'd my solder go? Oh, there it is. That's right. I haven't used it in a little bit. All right. Check the focus again. Checking the coffee again. Let's wait for that magic beep. That should be close enough. All right. People ask about the solder fumes. I do have a fan that I often run, but it is noisy. And if I'm going to die from this, I'm probably already doomed. I've done this so much. But then again, I'm from the generation that rode bikes without helmets. I'm surprised I'm alive anyway. No car seats. Back seat of a 74 Chevy station wagon, facing backwards. No car seat. No seat belt. I'm still here. Actual prizes and cereal. I'm old. And cantankerous and set in my ways. I'm set in my ways like that wire set in that solder joint. Let me put a dome here. Attach this bias wire to the tremolo here. This bias wire connected to the tremolo is there so that at the moment that you switch the tremolo on, it provides a jolt of voltage which kickstarts the tremolo circuit. Otherwise, it can take a few seconds for it to start ramp back up. So if this wire became disconnected, the tremolo would just be slow to engage, so it wouldn't hurt anything. If this wire, the bias wire going to the bias supply, were to fail, bad things would happen. All right, so I will heat up my big iron in a moment and get this old iron out. This old wire out. In the meantime, I'm going to cut it a little bit shorter. Maybe just enough for me to grab and pull out. And I can go ahead and trim the excess of this new bus wire. And that'll reach where it's supposed to go. I'll show you that later. Oh, actually, let me move the camera and show you that now and where it's going to go now. And the screen grid resistors. I'm going to do those next. Very fancy camera work. Let me flip the screen around so I can see what I'm looking at. Pardon the bench clutter. All right, so the new ground wire is here. I'm tilt it up so you can see it. The new ground wire is here. The old ground wire is there. I'll redo that in a little bit. Right now, I want to look at these two replacement screen grids. These are non-original, and as I mentioned before, they don't look right. They've got some discoloration. I just don't trust them. They've got like a crackle texture to them. These are not original to the amp. I think I mentioned that. So they are not getting sent back with the amp. They're getting tossed. And as I believe I showed in that Bassman video, I want to get the solder out. Each one of these lugs on the tube socket has got two holes in it. I want to move the actual wires to the lower hole. Makes it a lot easier to fit the leads of the new component in the top hole. That's the screen out. There. Screen out on there. Let me remove that old solder. That takes care of pin 6 at each one. Let's do pin 4 at each one. Sorry about hitting the camera there. Did it again. Sorry. It's not in the best spot for me. Get my braid. Get a little bit off this one here. Again, I should point out that this amp is unplugged. In fact, the power cable has been removed, and there is no voltage inside. So a lot of the things I'm doing in here are totally safe, but if you're just start doing this off, in your amp, unplug it from the wall and start doing it, you might have voltages waiting to get you, or especially if you're still plugged into the wall, even if it's powered off. So there's a lot of safety precautions. I've discussed them in other videos. I can't do the entire disclaimer every video, every time. Nowhere in my videos do I say, so you need to do this. Yes, you, James McGovern of 47 Mockingbird Lane, whatever, take your life in your hands based on what some guy on the YouTube said. This is what I do, and I discuss the reasons behind why I do that. But there are other ways to do things, and there are safety considerations and other boring things that don't really apply to us kids of the 70s. All right. Now, there are different trains of thought on how screen grids would be applied. Fender always had them right in here, right over the tube socket. I think they did that so they could populate everything pretty much on the socket before the tube socket was installed in the amp. That is a terrible place for a resistor to be because it's right over all the heat from the tube. So you're going to have accelerated failure modes. Marshall tended to mount them up in the air, and that works pretty well too. My preference is to do them, especially these low mass ones that don't have any real weight to them, off to the side. Gets them farther from the heat of the tube, less likely to touch anything it's not supposed to, and should one of these burn, it can happen with a tube failure, they're less likely to burn things that are adjacent, and I'll move heater wires up out of the way. It can look in some of the videos as if this lead here, when I'm done, is touching these screws. That's usually a trick of the camera angle. There's always like a ½ inch or more of distance between them, and they're not going to move. The other thing is some people will really tightly wrap the lead around the pin on the socket. They want it to be really, really secure. And I've spoken throughout this video and every other video about mechanical connections being important. That's one place where I think it might be okay in case a resistor were to get really mega hot for it to kind of desolder itself. Because if a screen grid resistor disconnects itself because of heat, anything hot enough to make that solder melt, it's going to protect the rest of the amp because that tube, which is drawing that much current, will stop drawing current. It won't operate anymore. So I have come down, if someone has an argument, I'm persuadable if there's a better way to view it. But I'm currently and seemingly successfully of the view that under normal operation, it will not fail. Because specifically with these low mass resistors that I use, these Vishés, and should there be a failure mode, typically what happens with these Vishés, and you can see it in that Victoria video the other day, is that the resistor itself will just go open without charring anything. So it sacrifices itself. But if it were to generate, I need to get some excess solder off this wire. If it were to generate enough heat, it would just desolder itself rather than burn. So I don't think screen grid resistors need to have a rock solid, absolute reliable mechanical connection. I think that might be a place to let them have a built-in secondary failure mode. But again, I'm specifically using these Vishé low mass wire wounds that fail gracefully thermally. They're going to fail very rarely. There has to be an actual problem, in which case they will give their lives and act like additional fuses without damaging anything adjacent. Now, I didn't get quite enough solder on one of these two here. Doing the wires first. There it goes. Now on the resistor itself, I'll trim them roughly to length. Maybe about, 5/8 of an inch. I can measure it precisely if necessary, but it's never been that necessary. I just kind of eyeball it and it turns out to be, let me measure it now. That's okay, yeah. Actually about 1/2 inch, not 5/8. Just want it to go in there on each side. And want to stay in place mechanically before I solder, even though I'm not doing a wrap. It's one of the few places where I will just tuck the lead in and solder it, because I want for it to be possible for it to fall out if necessary. All right, let me add some solder to one side of each so I can position it where it wants to be, because right now they're too close to those screws I was talking about. So hard to do this with the camera where it is. Then I solder the other side. Now that the other side is connected, I sometimes want to reflow the first one, because the first side sometimes moves around a little bit as the solder cools. I don't want to have grade bad joints there. Just because I want it to be able to desolder itself in the event of a problem doesn't mean that I expect it to come loose. So those are to the side and up and well away from those screws. That usually does the trick. All right, so I've got to redo the AC wiring. I'll do that later. I've got to redo this one chassis ground I mentioned. The last thing to be done at this level is just changing out the cathode bypass caps on the board. Like I showed before, I'll show one, how I do one. I'm not going to show all 5. And then that's where this video will stop. So let me move the camera over for that and run to the kitchen for a bit. We'll be right back and finish this up. So I'm going to replace this previously replaced cap and these 2 dual sections. I'm just going to show doing this dual. And I have suspicions that this roach has already been replaced. We'll get there. Let me zoom in for you. We're just going to look at this one. So once again, while the iron heats up, the negative lead of this cap is the same bit of metal that goes to the chassis. So I'm just going to snip that with a little excess length. So I can bend that back on itself for good mechanical support. And in the meantime, I'm going to get the solder out of these eyelets. And I'm going to pull the wires going to the cathodes out, the leads, so I can be sure I have a good mechanical connection on everything before I resolder it all together. All right, now I'll get the solder out of these eyelets. Let's see if I can zoom in here and point something out. Well, I'll zoom in post. Look right here. As I heat the board up, heat the eyelet up, rather. The board itself is sizzling. There is moisture in that board, and that's the kind of thing I'm talking about. I want to get all of that out because that's what gives us leakage in the board. DC forms new pathways through the board. The board is supposed to be an insulator, but as it absorbs moisture, it no longer becomes fully insulated. And so when you see actual bubbling coming out of the board, that board has soaked up an awful lot of moisture over the decades. Now again, I mentioned this wire I want to bend back on itself for mechanical crimp, so it cannot pull out in the future. Sorry, the camera is not in a good place as far as where my arms need to go. So I'm going to soak this area in the board in isopropyl. And as I showed in that Bassman, a lot of times I will pull the backing board out. I'm not sure if it's going to be necessary here or not. We'll find out. And the first level of this is getting surface gunk off. Just getting surface yuck out. And it is so bad, I want to lift these two resistors up. Just a minute, I'll measure them. Normally I would measure them without lifting them up, but I want to get that area of the board really clean first. I'll clean the rest of the board later. Now, once again, I want to get that last little bit of solder out of there. This is also going to heat up the alcohol that's in the board there. All right, now I want to heat up these eyelets directly. You can see steam coming out. And there's a sizzle along this edge of the board. I have found often, for whatever reason, that the edges and sides of these Fender boards get yuck on them. And become problematic. I'm watching it. It's spreading. I think it may need more than one treatment. Getting a lot of yuck boiling out of the ground as well. Let me remove these resistors completely. I'll be putting them back unless they're bad. I'll measure them in just a moment. This is not usually necessary, this level that I'm doing, but so much contamination. It's really gross. Come on. The camera is right where I want to put my right arm. It's hard to do this on camera. And it's, every time I put the soldering iron back, my arm blocks your view. Sorry. A little bit more. Hear that sizzle. I don't know if you hear a sizzle, but it's there. I'm being careful not to get it on the white paper label of that Ajax cap. As mentioned, I don't want the ink to run. or fade. And I've got the iron set to 750 degrees Fahrenheit. Which really heats the hell out of these eyelets. All right, I'm not seeing any movement on the board at this end anymore. I think I've got all that stuff out. All right. So let me measure those two resistors. So we have here 0.895, so an 820 ohm, and a 2.934, so that's a 2.7 K from the tremolo. So the resistors are within spec. I'm just getting old bits of flux and yuck off the ends. Hook them back under the eyelets mechanically. Making sure they don't overlap each other at the ground end. That's good. All right, so that's going to be a nice secure connection. And we don't have all that yuck. As previously shown in that Bassman video, the old cap had 2 positives and 1 negative. So I'm going to redo that with 2 modern Vichy 63 volt 22 microfarads. And before you ask, though I've answered this a lot, there is no significant difference between a 22 microfarad and a 25 microfarad. You won't hear any difference in this. The filter that this causes, as far as AC frequencies go, between, say, 820 ohm with the 25 microfarad versus 820 ohm with a 22 microfarad, are so close together. I mean, they're really, it's like the difference between 0.7 hertz and 0.73 hertz. It's not, I think it's like 7.73, something like that. I have to look it up. Anyway, it is right down at the verge of almost below human hearing. You're not going to get any significant difference there. So we tin the sections where I twisted them together. I showed this more thoroughly on the Bassman video. So they won't come apart. Put them pretty much where they're going to go. And the negative's going to bend right there. And once again, I always like to have the value visible on such things. So the next tech can say, oh, use Vichy 22 microfarad, 63 volts. They can look up the data sheet and say, oh, those things are rated for however many thousand hours at the average temperatures found in the Fender. Those are probably still good. And according to this service record, that work was done in May of 24. Probably not a bad cap, or, oh, it's been a long time. Time to refresh those. I spent more time on this issue in the Bassman video a couple weeks back. And one of the reasons I do the 2 negatives like this twisted together is because a lot of the Fender eyelets have so many leads in them that trying to get 2 more in there is really tough. So combining them to 1 not just looks more like how it used to be, but it actually works better. So that's going to go down about there. want that to bend back on itself. That cathode goes in there and hooks on itself too. This one does. All right, so those are all three secured before solder is applied. Wait for the beep. I'll go back and dome that once this next one's done. Well, I'll pair up this. I can see moisture is in the cloth on this blue and this yellow wire. Those are grids coming from that side of the board over here. That's isopropyl that spilled while I was doing that cleanup. That will evaporate. But when you do that stuff with isopropyl, that's the kind of thing you want to wait before you power it up on. You can help it out sometimes with I use a heat gun. Sorry, I dropped the tool. Hair dryer will do the job as well. And as I showed in that Bassman video, undoing these screws that hold the boards together and pulling the board up in the air helps everything evaporate between the boards as well. I will probably end up doing that on this board, just not in this video, because it's been a really long one anyway. It's one of those things where people say they love these videos, and a large number of people do love these videos, but I see the analytics and I know how many people watch the whole thing versus watch 3 minutes. So this kind of video is not going to do all that well for me, but I'm not here primarily for clicks. You know, if you really enjoy what this channel does, I think having this kind of long, detailed video once in a while is a great benefit to all of us, even if there's not immediate monetary benefit to me. On that note, for anyone who's made it this far, when I can find the time, I'm going to set up a Patreon for you crazy people who really do like this stuff, because I'd love to have stuff like this out there on the channel, you know, long detailed repairs in 4K with good quality audio and all that. But YouTube is not set up in such a way where that would be of any financial reward for me. And I already have enough business doing the amp work that I don't need to make these videos, at least not at the frequency with which I've been releasing them. So I'm going to be setting up a Patreon so that this kind of thing can continue and maybe even get better. But as far as drumming up work, I could probably do 2 videos a month and maintain. But more the fool me, I like this process. I've learned to enjoy this side of things. So I will continue. I just want to make it a little more feasible. Besides, where else are you going to get your battery reviews? Bad battery. Okay, so like I said, I'll do this one next, same way I did that. And I'll do this one, which is very simple, but this is how I do those things. And it's very secure mechanically and electronically, and it looks nice. Everything needs to evaporate. Be other sections of the board that are also full of, coated in contaminants. I can see some here. Let's see, tilt this up for you. So yeah, lots of spaces in the board will get clean, especially here at the plates, these plates, and right in here. Let me show you this before we wrap up the video. It's very common for there to be DC here, here, or here. Let me get a pointer so you know where I'm pointing. At this eyelet, which is coming from the normal channel, this eyelet, which is coming from the vibrato channel, or this eyelet, which is where the two resistors, the 220Ks from each channel, merge going to the input cap to the phase inverter. And that happens because the board gets dirty, full of contaminants, both in it and on it, and there is fairly high voltage, typically 50 volts-ish, present at this eyelet and at this eyelet, which is this is the cathode resistor, this is the tail resistor in the phase inverter. And again, just like in other places in the amp where you have, you can't see where I'm pointing, but anyway, voltage can develop from here to here, or here to here, or here to here. And so cleaning this area of the board, just like I showed here, can do wonders for getting rid of staticky, yucky sounds. So as grimy as this board is everywhere, and as much as it was bubbling over there, I think a lot of that is in my immediate future. I'll spare you those details in this video, though. For those who've watched this long, make up your own code word, and then people will really wonder what we're talking about. Thanks again, as always. Thank you for watching.